Welcome back. Another one. Where do you find a dog with no legs? Right where you left him. Sad, sad. All right, so we've got another video on logs. Today we're talking about log laws, okay? Now, the easiest way to talk about log laws is, you know how indexes, logs is a type of index. So it's kind of like how we have index laws, we're also going to have log laws, and you'll see that they're somewhat similar. Now, just a side note here, when we're talking about logs in your calculator, if you press the log button, that means we're talking about log base 10. And then there's an in button, or it looks like an in, but really it's ln, and that's going to be log base e. So just remember, your calculator can only calculate it if it's base 10 or base e. Okay. Now, because logs are the inverse function of exponentials, it's kind of like the opposite. The way that it works is if I take a log of an exponential, so there's my log, there's my exponential. If I kind of take one of the other, they kind of end up canceling each other out, and it kind of just leaves me with x. And the same way, here's my exponential, here's my log. Guess what? They cancel each other out, and my answer is x. Okay, so that's one thing to keep in mind as we I guess continue this topic. Now, if we just really quickly remember our index laws, if we multiply our powers, by the way, you should probably pause the video here, see if you can complete all these on your own. If you cannot, good luck. So we've got a to the m times a to the n. Hopefully you remember here that we need to add the powers. If we divide with the same base, we actually minus the powers. If it's a power and I raise it to a power, I multiply the powers. If I've got a to the 0, anything to the power of 0 is 1, and anything to the power of 1 is itself. Okay, now what we'll see is we'll actually see that there's a it's like same, but different. Okay, those are your index laws. Let's take a look at our log laws. So here is actually what we call a product. So the way that it's going to work is it kind of works backwards. So now this is going to be log ax plus log ay. So we can kind of see here that multiply relates with the plus. Okay, so if you think about it, this is a quotient or a division. So instead, divide normally correlates with minus. So this one's going to be log ax minus log ay. Now just keep in mind, see how the order is important. The x was the numerator, so that means the x is the first term here. Okay. And if I talk about this one here, this is probably like a less commonly known one. And this is probably the most helpful one. Whenever I have x to some sort of power, a power kind of means that we multiply. So this is where the power actually comes down to the front, and then our log remains the same. So we can kind of see that a power is kind of like multiplication, kind of like our index law here. Power of a power means kind of multiplication. Hopefully, I'm hoping that you guys are catching the difference or the similarities here. So if you're not, take a look. Okay, product is with plus, product is with plus. Division is with minus, division is with minus, right? This is what I mean. Same, but kind of different. Okay, and same thing, log a1, it's saying a, what it's trying to say here is a to the power of something gives me 1, and I know that something must be 0. And very similarly, if I'm talking about this one, I'm saying a to some sort of power should give me a, so that must be 1. Okay, and these here are your log laws. Now let's take a look and see if we can use these log laws here to simplify some expressions. Okay, I've got 3 here. Now here I can see that I can see that I'm adding 2 things together. So that means it's talking about the product of those 2 terms. So an easier way to simplify this is I could say this is log a of 6. Okay, now I'm looking here again, I've got the same base. So, and I've got minus this time. So this time I know it's going to be log 6 and then 12 divided by 4, or 12 over 4, or we know that that's going to be 3. Hopefully you caught that. And this last one here, there's a couple of different ways to think about this one. I think the easiest way would be to kind of deal with this power here, move it down to the front. So it's going to be 2 times, because remember, power means kind of like product. And then we've got log 7, don't know why I did a bracket. And then I've got take away log 7, 1. Now there's a couple things that we need to note here. Log 7, that's actually 1. And then minusing log 7, 1, I'm pretty sure that's going to be -0, looking at our log law. Anything where 1 is the numeral, it's to the power of 0. Okay, so looking at this and following BODMAS, hopefully we can see this is 2 take away 0. Just answer 2. Okay. Now there is one more type of question that we'll see. Sometimes they'll give us some approximations, and then we need to kind of find different expressions. So in this case here, I want you to take note. Given us log 2, 3 and log 2, 5. Okay, and what we need to do is we need to find out, okay, how do I make log 2, 15? And so hopefully you can see that with 3 and 5, the logical thing would be to go 3 times 5. And we know by log laws, we can actually write this out as log 2, 3 plus log 2, 5. Now, why would we do this? Is because we know that log 2, 3 is approximately 1.58. And we know that log 2, 5 is approximately 2.32, because they've told us. And at this point, you just add them together. I'm going to do this in my head, 3.9. Yeah, so it's an approximation. We have found our approximation. Okay, now they could do other things here. In this case, it is log 2, 0.6. Now I'm thinking, how do I get 0.6 from 3 and 5? Now, you have to be a little bit creative at times. Now, I know that's it'll be the same thing as 6 on 10, which I know can also be written as, I hope you guys said it at home, 3 on 5. Okay, 0.6 is the same thing as 3 on 5. Now, the reason I like this one is, look at my numbers. Boom, I've got my 3 and 5. So now I know with a quotient, it's going to be the same thing as log 2, 3 take away log 2, 5. Now, what is log 2, 3? We said from before, it's approximately 1.58. And if I take away log 2, 5, it's take away 2.32. And I'm going to need a calculator to quickly do this. 1.58 take away 2.32. It is approximately minus 0.74. Okay. Log 2, 9. I know that I can write this as log 2, 3 squared. And again, why would I choose 3? Oh yeah, because I know what log 2, 3 is. And so using my log law, I know I can bring my 2 down the front. And it's going to be 2 times log 2, 3. What is log 2, 3? It is 1.58 approximately. So our answer is approximately 3.16. Okay. And last one, log 2, 10. Now this one, a lot of people aren't going to see coming, because you're trying to think, okay, well, how do I get from 3 and 5? How do I get 10? Okay, this is a secret one that a lot of people forget, but I'm going to do this. Will 2 times 5 give me 10? The answer is yes. I know what log 2, 5 is. Do I know what log 2, 2 is? Yeah, because what is log 2, 2? Even though they didn't tell us, I know for a fact that's a log law. That's 1. Okay, so looking at this, I can now rewrite it as log 2, 2 plus log 2, 5, which is log 2, 2 is 1, which we said. Then log 2, 5 is approximately 2.32. So approximately becomes 3.32. Okay, hopefully that makes sense. We'll save that one for the next one. See you guys later, and bye-bye.